Okay, having a look at the question 19 from the 2024 tech-free paper for maths methods. So we've got a permanent ice glacier is in a valley in New Zealand. Due to the temperature changes, the glacier expands for 6 months, recedes for 6 months. So straight away we know total of 12 months there. The changing distance of the point on the edge of the glacier to the car park can be modelled by a sine function. So that 12 months is going to be our period. And we know that it's a sine function, so our y is equal to a sine bx plus c plus d. So during the colder months, it expands. The front edge of the glacier moves to within 270 metres of the car park. However, in the warmer months, it recedes and moves to 280. So it's a total distance of 10 metres that it's travelling, which means our amplitude is going to be equal to 5, because that's half of 10. Also, we need that mean value, which will be 275, because we've got the 270 and the 280. So our d is equal to 275. So we can then write y is equal to 5 sine of, and we need to get our b. So if our period is 12 months, our b is equal to, our period is equal to 2 pi on b. So that means we've got 2 pi on 12, which is the same as pi on 6. So then we can write 5 sine of 5 pi on 6. We don't have a phase shift given to us any information regarding that, so we're just assuming it's from 0. And then we have the plus 275 on the end. So we've got our equation that we need to work with. Then it talks about this acceleration. So this is our position. To get the acceleration, we need to do the double derivative. So our first derivative is going to be bringing out that pi on 6 out the front times 5, changing it to a cos, pi on 6t, if we put the t up there. So then our double derivative is going to, we're just going to do that again. So it's going to go to negative sign. So we've got the negative, we're bringing out that pi on 6 again. So we've got negative 5 pi on 6 squared, sine pi on 6t there. So now we've got that equation for the acceleration. We then want to use that other piece of information about the 5 pi squared root 3 on 72. So we're then trying to solve for t there. So we're substituting that in and solving for t. So we're putting that into our equation there. So we know that the 5 pi squared root 3 on 72. So that was our equation from here. That is going to equal, when we put that in over here, our negative 5 pi on 6 squared sine of pi on 6t. So then looking at what we can do to cancel out. So the 5 can cancel out. We can also cancel out the, we've got pi, and that would be pi, like pi squared there, so that can cancel out as well. So we end up getting to a point where we have negative sine pi on 6t is equal to root 3 on 2. Then you are going to solve where that would happen. And so that means your pi on 6t would be at 4 pi on 3 or 5 pi on 3. And then you're going to change that into months. So to get the t there, divide through by pi on 6, and you'll get your t is 8 or 10 months. Then that means that you're looking at a 2-month period of time. You can then solve for that t value, and you would be then looking at the fact that that is 4 months of the year. So then that claim of being 8 months is unreasonable. So that's the process you would go through for that question 19. Remembering that this is the last question on the paper, they are not expecting very many people to fully finish that question.